are mobile in the plant, and some nutrients, and the mobile nutrients you'll first see the deficiency on the older leaves if they're mobile. And some nutrients are immobile in the plants, and in that case, you'll first see the deficiency in the younger leaves. And what this means is if the nutrient is mobile, then when the plant starts to become deficient, like it needs more of it than it can get from the soil, it can repurpose that nutrient from the older leaves and move it up to the new growth. So that's why you see deficiencies first in the lower leaves for nutrients that are mobile. The plant will reuse the nutrients from the old leaves so that it can keep growing. Potassium is an example of this kind of nutrient, and this is one of the ways you can help diagnose nutrient deficiencies by looking at the leaves, is by memorizing which nutrients are mobile and which nutrients are immobile, and then that combined with the symptoms that you observe, so the symptoms, the colors, and where they show up on the plant, that combination helps you figure out which nutrient is deficient. The immobile nutrients, iron is an example of that. So even though the plant needs more iron for its new leaves, it can't physically remove it from where it stored it in its older leaves. So you see the iron deficiency symptoms on the new leaves because it's an immobile nutrient. Here in your slides, there's a chart which is a little too small because it's a lined portrait and the slides are landscape. But you can find charts like this online for your study as well. The immobile nutrients are calcium, sulfur, iron, copper, zinc, and boron. And those, you'll see the symptoms of deficiency in the new baby leaves first, the expanding leaves. The mobile nutrients are nitrogen, phosphorus, and potassium, those the three macronutrients, so that's pretty easy to remember. And you'll see the symptoms of nitrogen, phosphorus, and potassium deficiency first in the older leaves. Manganese and magnesium are kind of intermediate. You see sometimes the nutrient deficiency first in the young, fully expanded leaves rather than the older or the newest. But all of these symptoms that you can study, they show up in complicated ways, often not exactly like they show up in the perfect pictures in our books. Here is an example of nitrogen deficiency. This was a research trial from Oklahoma, where here this row of corn got 100 pounds of nitrogen fertilizer per acre, and this row of corn got 0 pounds of nitrogen per acre. And you can see this corn that got the nitrogen fertilizer is nice and tall, and this corn that didn't get any nitrogen fertilizer is short, but they're both pretty green. They're not really showing that classic nitrogen deficiency symptom of yellowing. There's just physical stunting happening. So sometimes these symptoms show up in different ways than just the colors. Another thing to be aware of is this graph. The bottom axis, the x-axis, is the concentration of the essential elements from very low to very high, and the y-axis is the relative plant growth. So at very low concentration of essential elements, you have very low plant growth, and it gets better, and then you have this optimal range where it plateaus. And for some elements, if it gets too high, then you have toxicity and the plant's growth decreases again. The thing to remember, though, is that those plant symptoms that we talked about, like the colors that you see show up on the leaves, those show up at the very low end of the spectrum. And when, in many cases, we're going to talk about an exception later, but in many cases, once those symptoms show up, you're kind of already too late to fix the problem and get the maximum yield out of your crop. The more mild deficiencies, those really only show up. So it's important to do soil testing. Another reason it's legally required, but also it's very necessary to grow your crops well, because the soil testing will tell you about these problems before you encounter them in the field. And similarly, if you have optimal nutrition, it'll tell you that so you don't have to waste money on stuff you don't need. So soil testing is important. It's written in kind of fuzzy, though, to show that soil testing doesn't tell you. Soil testing tells you about the nutrients that are in your soil, not about the nutrients that are in your plant. Foliar testing is when you take the leaves of the plant itself and send that off to the lab, and that tells you about the nutrients in your plant. And that's can be a more precise way of measuring the nutrient status of your plants. It's especially important for some horticultural crops, like tree fruits, small fruits, grapes, things like that, to get really good idea of the nutrient status of those crops and give good nutrient management planning recommendations. You often need to do foliar testing. So at the very low concentration of elements, that's where you see visual symptoms. This low level here, though, that's what's sometimes called hidden hunger, where the yield might be depressed, but you're not seeing those deficiency symptoms, those color changes in the leaves. And that's only going to show up with soil testing or with foliar testing. So can the concentration of a nutrient be too high? Yes. But toxicity is only a problem with some nutrients. However, in soil water, nutrients are ionic. If they're too abundant, the soil water may be too salty. So the classic example of this is nitrogen. We don't really see nitrogen toxicity. Too much nitrogen doesn't build up in the plant and cause like toxic symptoms, but too much nitrogen can be too salty. It can burn the plant roots. That's what we talk about when we say that the fertilizer or the manure is too hot and you put it too close to the seed or the seedling and it burns the plant roots. And again, as we talked about a couple before lunch, high concentrations of one nutrient can interfere with uptake of another. So even if you don't have toxicity from too much phosphorus, that phosphorus might bind up all the iron in your soil and then cause iron deficiency symptoms. So with some nutrients like boron, toxicity is very much a problem. With other nutrients, if they have high enough levels, they cause other problems before they cause toxicity. Deficiencies, too little, and toxicities, too much, they can occur even if your soil test levels are good and optimal. So the soil test is a really important thing, but it's only one piece of evidence about how your plants and your soil are doing. So if you have a drought, that soil water flows more slowly, less nutrients get to your plant roots. Your plant might reduce evapotranspiration, take up less water, try to survive the drought, less nutrients get up into the plant. A drought can also cause salinity problems. And high salts in the soil can restrict root growth and interfere with nutrient uptake. Waterlogging, even if your soil has optimal nutrition, that will limit oxygen access to the roots. That can kill off root growth. It can induce nutrient loss through leaching, and it can induce nutrient toxicity by changing the availability of some toxic nutrients in the soil. Temperature, cold soil can restrict below ground root growth. So if the roots are growing too slowly, it can temporarily cause nutrient deficiencies. And pH, if the pH is at the wrong level, outside that 6 to 6.5 range, that can cause deficiencies and toxicities, even if an appropriate level of nutrients are in the soil, they're just not as available to your plants. And then a really low pH can reduce the capacity of the soil's cation exchange capacity to hold nutrients, which can cause more leaching. Here is an example of drought-induced boron deficiency in grapes. It causes this kind of stunting of leaves and fun growth patterns. And here is an example of, early season deficiencies in corn. This is either sulfur or zinc deficiency. They look really similar, and they both can happen early in the season when the soil is cold, when the roots just aren't growing that fast. The good thing to remember, though, about early season deficiency symptoms, I know earlier I said once these symptoms show up, you're kind of too late to solve them. This is the exception to that. If for early in the season you start to see deficiency symptoms and the soil is cold, sometimes plants will grow out of that if there's enough in the soil to begin with. So if you got good soil test results, you know you applied your fertilizer right, but you're seeing deficiency symptoms and it's cold out and your plants are still little, that might be early season deficiency. And here's the fertility specialist from University of Minnesota explaining one summer, I think this was a crop update they had one spring, that there was unfavorable conditions for crop growth that spring. So he was getting a lot of questions about young corn showing deficiency symptoms. And he said that's not cause for immediate alarm, but if those deficiencies continue after the growing season, conditions improve after it gets warmer, then we need to worry. But it's important to check that this is actually the problem before you try to correct it. Because if you're treating the wrong problem, you're not going to cure it. So he was suggesting maybe doing tissue nutrient analysis. So that's the deficiency symptoms section. What can growers do to maintain soil fertility? Again, way back at the beginning, before lunch, we talked about how there are a lot of different factors that limit crop production. Soil fertility is just one of them. Nutrients are just one of them. So there are two main things to recommend. Maintain good soil organic matter levels, 3 or 4%, and follow your nutrient management plan. Those are two of the best ways to maintain good soil fertility. Also optimize pH, get pH in the right range. And those three things will really do the biggest, do the most you can. And reducing erosion as well, which isn't on this list, but is really important. So before you start trying to do anything too wacky or what salespeople are trying to tell you, pH, soil organic matter, nutrient management plan, erosion, everything else is kind of gravy. So if you have pH in the sweet spot, your nutrients are available. If you maintain soil organic matter levels and minimize erosion, then you're maximizing your cation exchange capacity. And if you follow your nutrient management plan, you make it unlikely that crop growth will be nutrient limited. You can also make use of cover crops. Cover crops can retrieve nutrients from lower soil levels and bring them higher up. They can cover the soil to reduce erosion, and if they're legumes, they can introduce nitrogen into the soil. You can also occasionally utilize animal manures as a source of nutrients, as a balanced source, as a source of many different kinds of nutrients, I mean to say, and as a source of organic matter. It can be a good source of secondary and micronutrients, but beware of getting phosphorus to excessive levels. This has to do with the ratio of nitrogen to phosphorus in manure, because in some states that don't have the same nutrient management regulations that we do, people try to apply enough manure to get all the nitrogen that they need, and that results in too high phosphorus, right? Because the ratios aren't the same as what you would want. Made it through all the slides. Here is my contact information. I would appreciate it if you have a moment to fill out a teaching evaluation. You can go there on your smartphone. It's also on your slides. If you want to do it later at go.umd.edu/agteach. I am a public servant. You are the public. You get to tell me how well I'm doing my job. And do we have any questions before we continue? If you also have questions, you're welcome to email me or call me later. And I know Kayla is a wonderful resource for you as well on this topic. All right. Thank you all.
Thank you, Mia.